Hi everybody, welcome back. We're going to start 12.2 today. Really no new equations or calculations. We'll just be doing some problem solving with the trig functions that we've learned so far. Okay, there is some new vocab that we need to look at. And this picture that I'm going to show you here is in your book. It's on page 647. So don't worry about drawing this exact thing down. We'll draw our own version of it in a minute. But here are the two new terms for today. Angle of elevation and angle of depression. We're going to see a lot of scenarios where they use those phrases. That's going to help you draw your diagrams and draw your triangles. Okay, so what they are, and you can sort of tell from the picture there, but let me give you this description. If you are looking up at something, that we call that the angle of elevation. If you're looking down at something, that's called an angle of depression. Now, when you're drawing these on your own, if you see this term, angle of elevation, what you need to know is that it's always from some horizontal line looking up. So in this picture that's here, here's our horizontal line. Now this is at eye level. Usually, to be honest, it's normally more at ground level, but from there we're looking up, and this kind of, imagine you have like little laser beams coming out of your eyes. Where your eyes are facing between that and the horizontal, that's what we create. That's how we create the angle of elevation. So typically, again, an angle of elevation will be sort of ground level, horizontal, looking up. This is the angle that's created. And then somehow in there you'll be creating, we'll kind of drop down to the horizontal and create this little right triangle. So that's the angle of elevation. The angle of depression, let's talk about that one. Very similar, but it's from a horizontal looking down. So if we go back here, now here's the horizontal line, kind of at their line of where his eyeballs are, right straight across. But imagine again, little laser beams coming out of his eyes. This is where he's actually looking. This angle created right here is the angle of depression. So this one would be from a horizontal line looking down. Right here is our angle of depression that's created. And again, somewhere out of this, you'll get a little right triangle that is created. Okay, this one, imagine you had like a boat on water or something. You need some reason that you can be looking down from there. Okay, so let's try an example. This one, we have the angle of elevation from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. How far is the sailboat from the lighthouse? Okay, so we have a little boat. Here's the horizontal, kind of it's laying, on the water. The angle of elevation, so we're going from the horizontal up to a 121-foot lighthouse. So here's our lighthouse over here. We're going from the ground up. Okay, this angle right here is 16 degrees. And then they tell us that the lighthouse is 121 feet tall. And it is safe to assume that buildings, we talked about this before, buildings, trees, whatever it might be, is perpendicular to the ground. Okay, so this is the triangle that we're working with. Let me scroll down here. They have a nice, neat picture for us. We're trying to figure out how far apart they are. So in our diagram here, this is what we're looking for, that side X. Once you get to this point, these examples are exactly like what we've been doing the last couple of days. Okay, we start by labeling our triangle. Let me do it on this one here. Well, I'll stick with you if you're working out your notes here, and let's do it right here. So this is the angle that we have. We have the opposite side. We're looking for the adjacent side. Okay, if you think about SOHCAHTOA, this pen is the worst. Opposite and adjacent, we're talking about tangent. So we start out the same exact way here. Tangent of theta equals opposite over adjacent. Plug in what you have. Tangent of, we have the angle this time, no inverse trig functions in this case. Okay, is, let's see, 121 over x. Now this is the one that takes an extra step to solve for x because you have to multiply both sides by x first. Excuse me, so x times tangent of 16 degrees is 121 feet. So in the calculator, we're putting 121 divided by tangent of 16 degrees. It should be about 422 feet away. Okay, let me kind of pause since we're just doing this one example here together. Let me backtrack a bit. If I put tangent of 16 in my calculator, this is just a little note. Okay, tangent of 16 degrees is about 0.29. All right, so when we set up this problem right here, at this point right here, we are saying, okay, I have a 16-degree angle. Tell me what my other side would have to be so that I get this correct ratio, so that I get 0.29. Okay, and the calculator is saying, okay, well, tangent of 16 is 0.29. So in order to get 0.29 over here, and let's do this calculation. If you take 121 over this answer that we found, 422. Oh, that's pretty darn close, actually. It's about 0.2867. It's about 0.29. So they're saying in order for this kind of all to work out, to have this proper triangle that is to scale, you know, the angle's right, the sides are right, this side would have to be 422 feet. Okay, if this side is 121 and you want a 16-degree angle, the only side length you could have here is 422 feet. Like if you were trying to, you know, draw this perfectly on paper, and get an actual 16-degree angle and truly 121 feet, the only way that that's going to work out is if you make this side 422 feet. Okay, nothing more to do with that. I'm just trying to kind of get back to conceptually what's actually going on here because these trig functions are really challenging. All right, I'm going to ask you to do some practice problems from the book. I'll scroll down. If you don't have the book, you can just pause and look at these examples in a minute, but you should be able to, I put the link for chapter 12 on the Google Classroom as well. So we're just going to try numbers 10 through 14 on page 648. I want you to show me all of your work. So I want diagrams for every problem. I want your equations that you're choosing. I want to see you working that out, because what I'm going to try to do a little bit differently this time is give you some feedback right on the document that you submit to the Google Classroom, so you can, you know, fix any issues that you're having. If you can, try really hard to actually upload it to the Google Classroom. Some of you have been emailing me, and that's fine. It's just going to make the feedback part a little bit harder. So for today, try to submit it, attach it right to your Google Classroom assignment if you can. Okay, let me know if you have any questions. See you guys.